Hey guys, it's been several weeks since I actually made a video. I'm really trying to make a video every week or every couple of weeks, but sometimes life just gets in the way and I've had a very busy month, both professionally and personally. And I started this video actually weeks ago, but it's only been recently that I've been able to get back to it and finish it up. So the good news is we have our first FP versus FPL video. And it's going to be based around the noise between the two cameras. Now, noise is not necessarily inherently bad for three reasons. The first is that quite often we don't even see it. Right? When people evaluate it on YouTube, they often evaluate it very unnaturally. We're pixel peeping hundreds, sometimes thousands of percent, looking at every little individual flaw. And this isn't how people actually look at photographs. So quite often we're finding fault where fault doesn't exist. The second reason is that film or noise can actually be a good thing. It can give images that film-like look by providing a nice tight grain to it, right? So if it has a film-like grain, it can make it look vintage, it can make it look more energetic. Street photography looks great with grain on top of it, in my opinion. And the third reason is I like low noise because I do a lot of composite work. So when I'm compositing, I'm putting objects on top of objects, and I have to be concerned about things like light direction and color, but also things like luminosity, saturation, and noise, right? If objects have different grain, it's pretty apparent that they weren't shot at the same time. So if they're nice and clean, like in this particular portrait, this portrait was easy to do compositing because both the plate and the subject were virtually noise-free. However, although I want low noise to make compositing easier, quite often the last stage in compositing is to reintroduce noise. It provides a uniform grain from corner to corner, and it just gives the image a more uniform and cohesive and natural look. Now we're going to test noise by testing the camera's ISO in three different situations. The first is just going to be a base test. We're going to test in the studio where we get to control all the elements, the lighting, the subject, all the settings, the distance. And what we're really going to do here is look at a baseline. We're not going to get dramatic results because this is a situation where we normally aren't fighting with noise, but this will give us a good base to judge everything else moving forward on. The second test is going to be the real world test. This is where we typically run into noise. We're going to be shooting at night, doing like street photography at night when it's dark. We don't control the subjects. They're dynamic. We don't control the light. They can be very inconsistent. We may have to use a very fast shutter. We may not be able to get the perfect frames. We have to crop in post, or we may have to use dynamic range to pull the image out of post. All these things introduce a tremendous amount of noise, and this is where we're going to see where the cameras really can perform. And then the third test is going to be around video. Now, even though we're shooting DNG and Cinema DNG is just tons of DNGs, and it should be, theoretically the same, there are two big differences. The first is the sheer volume, right? Fixing noise in one image is not the same as fixing the noise in tens of thousands of frames. And the second thing is, let's be honest, not everyone shoots Cinema DNG. It's a big format, it takes special processing, and so you may use other formats and they can yield different results. And so I think the video portion is going to be very interesting. So with that said, let us look at our first test. So for this initial test, I wanted to use a simple studio setup. So I chose still life because that way the subject would be identical in every picture. And I also used continuous lighting, and that allowed me to ensure that every image would have the same light, the same intensity, the direction, the quality, and the color would remain constant. They both shot with the same lens, which was the 65mm I-series. And I used a tripod to guarantee the same distance each time, even the same tripod plate, so that the framing of the image should be almost spot on both times. Now the FP and the FPL had the exact same settings, well, almost. So I set the color for 5600 Kelvin on both cameras to match the color of the continuous lighting. But I completely forgot that I had done a previous project with the FP and had pushed the colors slightly more into the cyan. So there might be a slight difference in the color, but it's not much. It's barely noticeable, and it really doesn't affect the noise quality at all. So along with eliminating the variables in the subject and the lighting, I wanted to make sure that I eliminated as many variables with the cameras as well. I really wanted to focus on just purely ISO settings. So I kept both cameras at the same shutter speeds, 1/60th of a second, an aperture of I think 3.2 or 3.5. I then kept lowering the light so that I would have to adjust just the ISO setting. And eventually at about 3200 ISO, my continuous lighting was at the lowest possible setting. It was 1%. It was extremely dark, but these new cameras are just amazing in low light, and the FP is known for a great low light camera. So to restrict the light coming in even more, I started to then shut down the aperture as well. Now, I could have just played with the shutter speed, and that would allow the aperture to remain constant, and that makes it easier to compare like ISO 100 to ISO 8000, for example. But in this case, we're really just comparing the two cameras, and I wanted to control just the light entering the camera. And I know theoretically it should be the same with electronic shutter, but this way I took out that variable and I simply controlled the light entering the camera and used nothing but ISO to adjust for it. So let's take a look at some of the results. So here we're looking at ISO 100. On the left is the FP and on the right is the FPL. Now when we zoom in, we can see that both images look great. They're both clean, sharp, no noise. You can even see the dust specks on the color checker, which by the way is the object that we'll be focusing on for focusing. So as we move into larger apertures, we're still going to be focusing primarily on that color checker as a target. Also keep in mind that these are not exactly equivalent crops. Because of the different resolution in the cameras, they won't match up perfectly. So the FP has a punch-in of 100%, the FPL about 67%. Also keep in mind, this is really extremely pixel peeping, right? And this is one of the things that does bother me a little bit with YouTube reviews is that we really go to these extremes of pixel peeping. In this case, when you look at the lens of that camera, that is about 2 inches. So actually about 1.5 inches. So at this particular view, this would be the equivalent of about, I'd say, maybe a 6-7 foot print, right? Almost 2 to 2.5 meters large. That is a huge print in order to be able to see, this level of detail. So yes, when we crop in and we crop and we keep that crop, we're going to need that noise reduction. But if the image looks good, zooming in at this level really doesn't have a whole lot of meaning sometimes. But let's continue on. So here we're looking at 3200 ISO. This is where my continuous light was down to 1%. This is actually really, really dark. But you can see in both images, it still looks great. Now I picked 3200 because below 3200, they were really kind of almost neck and neck. Almost, because we'll come back to that in a moment. Hold that thought. But in terms of the shadow noise, which is typically what we start with, they are very, very close. 3200 is where I started seeing some deviation, but it's also where the camera's dual ISO kicks in. Now, I am not completely, up to date and knowledgeable about Sigma's ISO. They really don't give a whole lot of detail on how it works, right? There are different channels for anything below 3200 and above 3200, and that definitely helps with noise reduction. They always talk about it primarily in video, but if you're shooting cinema DNG and you're doing DNG photography, you would think that they would be the same in theory, right? So again, I'm not sure if this is true. If any of you are more knowledgeable about this, please let me know. But I thought it was a good point to start because we are starting to see some deviations. The FP is still holding together, I think, a little bit better on the grain. You can see that's a little bit finer. But the difference is you're starting to see some of the color shifts happen in the FPL. If you look in the very bottom corner, that red is becoming a little bit more pink. And this is what happens with noise. It's not just that we introduce artifacts. That's the first thing we think of. It gets that super grainy look. But there's also coloring, and it will shift the colors. In this case, because of the artifacts, we're starting to get more of a pink look. Now, keep in mind, though, that this is straight out of camera. There's no corrections in color or anything. Now, when you normally import your images into your raw processor, maybe in this case it's Capture One, but it could be another one, there's usually some default settings in those processors to apply some default noise reduction and some default sharpening. I turned all that off. So you're seeing like the ugliest, rawest image we can get. So keep that in mind because we're going to come back and look at that processing for the noise in a minute and see what effect it actually has. So moving on, now we're at ISO 8000. Again, both images look pretty good. FP on the left, FPL on the right. And when we punch in, we can see in this case that the FP is definitely starting to hold together a little better. We're starting to see more noise artifacts, definitely in the shadows. We're seeing the shadows shift, right? Blacks will shift to a kind of a hazy gray blue look. But again, look at that red in the right side, and you can see it's turning more pink because of all the lighter artifacts that are being introduced. Again, no correction has been applied yet, but this is raw out of camera. Keep in mind, we are again pixel peeping. This is the equivalent of easily probably a 7-foot print. And if again, you have to print really, really large to be able to see this noise, or you're cropping in really, really tight. As we move on to ISO 10,000, again, I think they're still holding together really well. I think the FP is seeing a little bit of shift in the background. Along with the FPL now, we're seeing a little bit more blue haze and gray being introduced into the blacks and the shadows. Still holding together very well though. But when we do zoom in, where again, we see that the FPL is showing a little bit more noise, and definitely the background is having a lot more color artifacts being introduced. So we're seeing a pretty big color shift here at 10,000. And finally, I took it to 20,000 ISO. And when we punch in here, we can see that both cameras are starting to be affected by the color shifts. We're seeing a little bit more blue and gray in the background, but definitely at this point, the FP is holding together much better than the FPL. Again, take it with a grain of salt because we are punching in pretty extreme in this case. Now, however, as I mentioned before, this is straight out of camera, right? This is no no noise correction, no sharpening, nothing. So what happens if we just applied the default Capture One noise reduction, not using a plugin, which is what I would use for photography because plugins are a lot more powerful and allow you to control the noise and the detail recovery. I just want to put the default denoiser from Capture One. What would it look like if we did that? And here is what it looks like. And take a look. I mean, the color and the shadows now are almost identical. FP may be slightly more creamier, but not a lot. We're really pixel peeping at this point. The difference between the FP and the FPL at 20,000 once you apply some default denoising is very minimal in most cases. Two things, you do give up some detail, right? When you're denoising, you're just going to get a little softer. Now you can use your default detail sliders, or you can use a plugin to get some of that detail back. But keep in mind that we're talking the detail that we lost, like the numbers around the lenses, those are they're a few millimeters, quarter inch. I mean, it's tiny. And this is we're talking a print that would be, 7 feet, 7 feet large. So we may be able to give up that little bit of detail, and it's still totally fine. We do see that the FP still holds that color together a little bit better. When you look at the red in the bottom corner, the FPL is still a little bit more pink. But I'm really actually pleasantly surprised on how well the FPL is held together at 20,000. Now, this is where I stopped because honestly, above 20,000, I just won't shoot. Because there's one more native ISO setting, and then you can put it into high ISO mode and push it up to, well over 100,000, I think. At that point, it's going to be extremely grainy, but there are legitimate times you want to do that, right? If you're taking photos of your daughter's soccer game and, you have to go to a low light noise situation, well, you know what? A noisy shot is better than no shot at all, right? So it's totally legit. But for me, for my work, and I think for most of you, once you start getting above 20,000 ISO, you're pretty high. And even after we apply some default sharpening, still, again, they hold up really well together. FP, you can argue possibly a little better, but they're really even. It's the color, and we'll come back to that. It's the color that's more of a problem than the actual artifacts and the shadows and highlights. Now, it's another interesting experiment. Some people might say, well, what if you just dial back the FP? It has all this resolution. What if we dial it back to a 6K, something that's more equivalent to the pixels that the FP has? Well, the problem with that is that although the resolution may be the same, those individual photosites in the FPL are still smaller, and they have less well depth and less light gathering capability. So in this case, the FP is all the way on the left, the FPL in the middle is 6K, and the FPL to the right is full resolution. And as we punch in, we can see that at 20,000, the FP, again, all the way to the left is holding together the best. The FPL all the way to the right at full resolution is doing not a bad job, but you can definitely see the bluing in the background, a little bit of haze, see some color shifts on the color checker. But in the middle where it's set to a 6K, it's actually the worst. Now, even after we apply some noise reduction, right, the background colors really all blend quite well, but there's still a little bit more grain in that 6K versus the full resolution. So this was just to show people that it doesn't matter what resolution you set on the FPL. By reducing it down from a 9K to a 6K, yes, you have the same resolution, but you have the same smaller photosites and you have less information. So you get the same noise, but less information, and that generally is going to make a more grainier image. So just a couple more things. As I mentioned before, for some strange reason, between 1600 and 3200 ISO, the FPL actually registered that it was gathering more light than the FP, about a third of a stop more. And so what you see here is on the FP on the left, this is 3200. The FPL on the right is set at, I think, 25. And when you compare the two together after noise reduction, man, they're pretty spot on, right? You get an extra third of a stop on the FPL. Colors look almost identical. It really looks great. Even when you zoom in extreme, you can see the two of them are really holding up almost neck for neck. So below 3200 ISO, They both really compare well in terms of artifacts in the shadows and in the blacks. When you get above 3200, you see the FP pulling ahead a little bit. It still holds itself together a little better than the FPL, but the FPL did a great job, and once you applied correction, it looked really good. But here's where the FP does a little bit better job than the FPL, and it's the color. So here we're looking at 1600 ISO, straight out of camera, no adjustments. And when you look at the shadows, they both look really good, right? They're pretty comparable. But when you look at the colors, take a look at the bottom blue squares and look at the blue as it goes up the steps there. And you'll notice the FPL has a lot more color shift in it. It's the artifacts that are coming in on those blues give it more of a paler look. Beyond that, like I said, you don't notice the noise in shadows, which is where we typically look. It really holds together well there. It's not the blacks that causes a problem. It's the color noising that seems to be a little bit more of a problem with the FPL. Keep in mind that the FPL here is slightly more magnified because of the resolution difference, which does exaggerate the noise a bit. Again, this is minor because once you apply some default noise correction, it's going to fix that. Like I said, if you look before, when we compared the 3200 against each other, against the 2500, it was super clean. You couldn't even tell the difference. But that's where I see the FP actually doing a little bit better than the FPL. Under 3200s, it still holds its color together really well in its raw format. Again, above 3200, it outpaces the FPL, but not by much. We're splitting hairs here. So what kind of conclusions can we draw after this first test? Really not much. This was a studio setting, and we controlled all the variables, the lighting, the subject, the distance, and so we knew it wasn't going to generate a lot of noise. But it really gave us a good baseline between the two cameras that we can use moving forward as we move into the real-world test and the video test. Honestly, I was very pleased and surprised by how well the FPL held up against its older brother, the FP. It generated little noise. What noise it did generate, it could easily be corrected in post. So hopefully we'll see this trend moving forward, and you guys will join me for the rest of the test. I'll see you then.